normally like I looked through your work and it looks like we need to return to the first page, but a little bit, but it's okay. It still will be like a light session, as you said, but um, like we have a little bit of like considering to do, or like a little bit of like it's okay cleaning up to do. Okay, so let's get to it. Um, First thing is, it looks like, as you saw on that first page, you need to do a number of like trig identities, right? Like, so you need to use the trig identities. Hold on a sec. Where's my pen? Oh yeah, it's hiding behind my keyboard. Okay, so um, yeah, so you need to use the sine squared plus cosine squared equals 1, blah, blah, blah. So first thing first, let me teach you a shortcut for memorizing them. Or like you tell me, how do you remember them? Like, so obviously, the first one, it's called the Pythagorean identity of trig. This one, sine squared theta plus cosine squared theta is equal to 1. This is like, in the trig world, this is like perhaps the most famous equation. So this one you should just know. And also like notice that if you like, subtract cosine, sorry, if you like solve for sine squared, you're going to get sine squared theta is equal to 1 minus cosine squared theta. And if instead of sine squared you solve for cosine squared, then you're going to get cosine squared theta is equal to 1 minus sine squared theta. And these are equivalent, obviously. All three of them are the same. So it's just a different rearrangement. So this doesn't count as like the latter two, if we call it number them, 2 and 3, they're not new. They're just one, like written slightly differently. But yeah, let me ask you, how do you remember the other ones? I'm sorry, say that again? Okay, sorry. Um, yeah, so here's a real quick way to like get to them, right? So first of all, what is secant squared? Like, what's how do you interpret, if I write secant squared theta, what's the meaning of that? Or how do you interpret it? I'll get you started. 1 over cosine squared theta, right? Yeah, you got it. So okay, listen. So if you want the identity for secant squared, as you just said, you want 1 over cosine squared. So what you should do is first write down this one, right? Which is sine squared theta plus cosine squared theta equals 1. And from, again, what we just said, secant squared is 1 over cosine squared. So you just write over cosine squared, 1 over cosine squared. But you can't just divide one side of the equal sign with cosine squared. You got to do it on both sides. So you divide this also, cosine squared theta, and of course also that. So all we have done is we divided both sides of this main one, the Pythagorean identity. We divided it by 1 over cosine squared. When we do, look at what happens. First of all, sine squared over cosine squared. What is that? Yeah, tangent squared. Absolutely. So you have tangent squared right there, plus cosine squared over cosine squared very obviously should be 1. The right side is clearly secant squared, and that's why we divided by cosine squared on both sides to begin with. So here you go. Here's the other identity, the one about secant and tangent. And of course, from here, you could solve for tangent squared and be able to write tan squared theta is equal to secant squared theta minus 1. Fair? Okay, now I want you to get me to the one about cosecant and cotangent, but I'll get you started. Again, you start with sine squared theta, sorry, plus cosine squared theta. Ah, Jesus Christ, what's happening? Cosine squared theta is equal to 1. So this time I want the one about, cotangent and cosecant. So what should I do? Like kind of similarly as we had done with the middle one. So what should I do to, get there? Mm-hmm. Yes, exactly. So we could start here and do what to get to that identity? I'll get you started. Divide both sides by. Yeah, yeah, trust yourself over sine squared. Now you divide both sides by sine squared. Earlier, we divided both sides of this Pythagorean identity by cosine squared, and then that got us to this one. Well, this one from which we got to that one. So this time, divide both sides by sine squared, and when you do, what do we have? You tell me. Mm-hmm. Square theta, exactly. And from that, you could solve for cotangent square theta and write cotangent square theta is equal to cosecant square theta minus 1. And again, these two are not actually different. They're one and the same. But do you see how we can start with the Pythagorean identity and get there every time? Yeah, you could do that. So that's an easy way to get there. Okay, now, so on the first problem, again, I looked at your work. It's good work, right? So you have cosine squared plus sine squared equals 1. And you're told sine squared is a third. So that turned into cosine squared if we skip to the third step. If you look at your paper, cosine squared plus 1 over 9 is equal to 1. I agree. And then you obviously subtracted 1 over 9 from both sides. And you got 8 over 9 on the right side. And then you took the square root of both sides. So then that meant you got cosine theta is equal to the square root of 8 over 9. So the square root of 8, well, the square root of 9 is 3. But then this means square root of 8 is what? Square root of 4, square root of 2 over 3. So that became 2 root 2 over 3, right? Okay, so one question I have is, how did you get negative 3 over root 2? Well, okay, so sorry. Um, since well, first thing we got, I'm sorry. So we have to consider the quadrants, right? Like we have to pay attention to the quadrant. Notice that at the start of the question it says pi over 2 is less than theta is less than pi, right? So what quadrant does that put us in? Wait, pi over 2 to pi. So pi over 2 is 90. Yeah, exactly. So which quadrant? Yes, exactly. We're in quadrant 2. Well, we know from the ASTC that in quadrant 2, only sine, and therefore its reciprocal, cosecant, are positive there. So now cosine is negative, in other words. Remember, anytime you take a square root of both sides, well, on the right side, you need to consider plus or minus. It's always plus or minus a square root. So it's plus or minus here or plus or minus there. But it can't be plus because, well, it's cosine and we're in the second quadrant. So we get rid of the plus, I'll erase, and so we keep only the minus. So that explains why you had to write. So really pay attention to these details, especially since your quiz is bound to be short. Like these details will make a difference, right? So I mean, like considering which quadrant you're in, blah blah blah. Okay, so you have this now. So if you have this, well, you need to get to the question is asking for secant theta. Secant theta is the reciprocal of cosine. So what you could do is like once here, flip both of them. So this is like, if you have, we've done this, if you have x over y is equal to a over b, then you could immediately write y over x is equal to b over a. Well, we just took this and flipped both sides. So just write cosine theta over 1, because, well, yeah, it is over 1. And if you flip both sides, you get 1 over cosine theta is equal to 3, well, it's negative, 3 over 2 root 2, right? Yeah, the only thing left to do is rationalize the denominator, unfortunately, because we still have a little bit of work to do, because, well, you can't leave a square root 2 in the denominator. Well, you knew that, so that's pretty easy to fix. We multiply by root 2 over 2, and so we get negative 3 root 2 over, well, we have 2, and then root 2 times root 2 is 2, so 2 times 2 is 4, so this is the final answer. Fair? Yeah, so I guess what I'm preaching in that first question is like, well, you did good work, like very good work, but in the end, we have to answer the question, which is you wrote cosine theta, but it's asking us for secant theta. Now, yeah, I wonder like how, valuable it is to go through the next one, but again, we will still be able to finish like on a relatively short time, so I'm just going to keep going. I'm going to do it real fast. Stop me anytime you have a question. So you need the cotangent theta is the question, and I'll of course ask you to chime in where I feel you need to. So you have cosecant is 1 over 5. Got it. So I'm not gonna reinvent the wheel and rederive like what we wrote over here. So you know how to get to these ones. Clearly we need the one about cotangent and cosecant, and that's this one, and it's asking you for a cotangent. So immediately use, well, this is the identity really that we got to from the Pythagorean identity, but the one useful is this version of it. Once we, as we already said, if we number them 1 and 2, these two are one and the same. They're the same thing. It's just slightly different arrangement. So use it in the version that is over here, like back here, right? So that's already solving for cotangent squared, and that's cosecant squared minus 1. So just come back here and be like, okay, cot squared theta is equal to cosecant squared theta minus 1. And then replace the cosecant squared, so cot squared theta is equal to 11 over 5 squared minus 1. That's cot squared theta is equal to 121 over 25 minus 1. And that's minus 25 over 25. And what does that say? Cot squared theta is equal to, what's 121 minus 25? Like, it's not a very pretty number. 121 minus, sorry, go ahead. Thank you. So 96 over 25. I'm not very good at arithmetic. Okay, now, so you talk a little bit beyond here. So what do I do next? Yep. So cot theta equals, yeah, so first of all, very crucial, plus or minus the square root of 96 over 5. And then, the 96, what is 96 divided by 2 is what? Like a lot, like 48. So 48 times 2, that's 96. But we need a perfect square. So we can break 48 again. And what does that give us? Like, that's 24 times 4. Okay, that's still 96. Can we get more perfect squares out of this? Yeah, because 24 is what? 4 times 6, so we could be like, oh yeah, this is 6 times 4 times 4, so that's 6 times 16. That's 96, right? And now we could take the square root of both sides and be like, oh yeah, so square root of 96 is the same as square root of 16 times square root of 6, and that's going to say 4 root 6, right? Yeah, just to explain how your teacher got there. I'm sure you would have gotten there on your own. I'm just like, okay. Anyway, it will help us for the SAT also, our SAT prep, so this is fine. Okay, now, so I have to ask, why did you elect the negative square root? I may be asking a rhetorical question, but go ahead. Yeah, because well, at the step where we took the square root of both sides, right? Like here, we had to write. We needed to write plus or minus on the right side. So why is it now the plus square root? Why is it the negative version? Yeah, let's see. So, but we are still in the second quadrant because the instructions are the same for all four of these questions, right? So we have 1, 2 in the quadrant. And so since we're still between pi over 2 and pi, we know that only sine and secant are positive, cosecant. Only sine and cosecant are positive there. The trig function we're talking about here is cotangent, so it's negative there. So that's why we had to get rid of the plus. Fair? Okay. So let's see. I don't think like it's worthwhile for me to go over 3 and 4 because the approach is much the same. If you feel otherwise, you can tell me and I could do them. But do you agree? Okay. I mean you hesitated there. Let me know. Like, are you sure? Okay, cool. All right. So the next one is like simplify the trig identities, right? So like the identities you use are the very basic ones, which is like cosecant is 1 over sine, blah blah blah, and like you also use the they're all of them together are called the Pythagorean identities. That main one, sine squared plus cosine squared, is the Pythagorean identity, but all of them, the other versions about the cosecant squared, blah blah blah, all of them are the Pythagorean identities. So what you're supposed to use for the problems 5 through 8 is again the very basic identities like cosecant is 1 over sine together with the Pythagorean identities and good things happen. For example, in number 5, you just wrote secant is 1 over cosine and then you have minus sine, tangent is sine over cosine. We know that the sines multiply to a sine squared. You already have common denominators ready made. So that meant like once you wrote, sorry, once you are at the step, let me refresh my pen. Didn't write for a second. Okay, so once you are at the step where you wrote 1 over cosine theta, um, and then minus sine squared theta over cosine squared theta, over cosine theta, as I said, this is already common denominator is handy. So the numerator becomes 1 minus sine squared theta. Oh, wait, 1 minus sine squared theta is gotten from sine squared plus cosine squared equals 1 by isolating cosine. So the numerator is cosine squared. I meant not isolating cosine, but isolating cosine squared from sine squared plus cosine squared equals 1. All right. That's easy. Okay, so then and the denominator is just cosine. So one of the cosines cancel, so the answer is cosine theta. Unsurprisingly, got it. Okay, so and the second one, cosecant squared theta minus 1 is cotangent squared. Again, you saw how why that would be like on one of the versions that we wrote, like of the Pythagorean identities towards the bottom on the first page of our lesson today, right? So like that's how you knew cosecant squared theta minus 1 is cotangent squared. But once you got there, cotangent squared is cosine squared over sine squared. So just a little bit of details, right? Like, and then you're dividing that by cosecant squared. So it'll be like divide by 1 over sine squared. Do keep flip change. So cosine squared over sine squared times, and then it's when we change the times, this is going to be sine squared just to save us some writing. This is going to be sine squared theta over 1. These cancel, and you're left with cosine squared, and that's how you got there. So I'm doing these very quick intentionally, but yeah, so 7, you did well in the middle grouping, like cotangent and tangent, right? Cotangent is 1 over tangent. That's cotangent. And then you have tangent multiplying it next to it. I'm just explaining why that would be 1 in case you didn't know. So that's 1. And then the rest of it, I think you got on your own. So I don't need to say more. And 8. So 8, very glaringly, what stands out is that you have cosecant in both terms. You have cosecant by itself, and then after the minus sign, there's a cosecant. So that's screaming factor me. So you do. Once you factor out the cosecant, you're left with cosecant times 1 minus cosine squared. But 1 minus cosine squared is that very first Pythagorean identity, sine squared cosine squared equals 1, where you've solved for sine squared. So 1 minus cosine squared is sine squared. So you replace it with sine squared. Cosecant is 1 over sine, so you change that. 1 over sine times sine squared is sine. Okay, done. So we're done with the first page. So we can go on to the second page, solving trig equations. So this is very, very, very important. And also, just like the very first set of questions on the first page, for this, you have to really pay attention to the quadrants given, right? So the quadrants given are all 4 quadrants, because it says 0 degree is less or equal to theta is less or equal to 360 degrees. So we have to look for solutions on all 4 quadrants. You did very well in your little drawing on problem 9. So now, like, obviously you have to get everything on one side and then the number on the other side. So the name of the game here is, you know how like for quadratics we need them to equal 0 for quadratic equations? Well, for these trig equations, what you need is the trig function all on one side and a number on the other side. So instead of equal 0, well, 0 is a number. You want it to equal a number, whether that's 0 or a different number, right? And so that's how you got to sine theta is equal to 1, because you subtracted 3 sine theta from both sides. So that meant, I'm looking at number 9. Once you subtract 3 sine theta from both sides, you have 6 sine theta on the left, and then plus 8 is equal to 5. Well, naturally, the next thing to do is to subtract the 8. So you get 6 sine theta is equal to 5 minus 8, which is negative 3. So the next thing you should do is divide by 6. So when you do, you get sine theta is equal to negative 1/2. Now, you have to look in all 4 quadrants. So all students take calculus says you need sine to be negative. All of them are positive in the first quadrant. That's why you X that out. Sine is positive in that quadrant, so we must be looking at quadrants 3 and 4. What I would do once I figure that out is immediately draw a reference triangle, because it's always reference triangles when you're like, you know, saying sine is this, blah, blah, blah. Okay, so just follow these instructions, which I'm sure you always adhere to, because, well, you always do. Anyway, just draw your reference triangles and label it so that the sine is 1/2. Now, the negativeness and the positiveness, you don't have to pay attention to that. You already took care of that by figuring out which quadrant you are. So we don't care that there's a negative in front of the 1/2. We took care of that again by electing the appropriate quadrant. So all you have to do is worry about the fraction, 1 over 2. You need sine to be 1 over 2. So that means that from the reference angle theta perspective, opposite side has to be 1, the hypotenuse has to be 2. Got it. Well, 1 and 2 are the numbers that are involved in the 30, 60, 90 degree triangle. The 45, 45, 90 has 1 and square root of 2. 1, 2, and root 3 are about the 30, 60, 90. So this is 1, this is 2, this has got to be root 3. So this has got to be 30. Got it. Sorry, 30, not 3 theta. Sorry, 30. So, I did it again. Jesus. Okay. Okay. Glad I made you laugh. So 30 right there. But that's a reference triangle. The actual angle is measured from the positive x, and so that's all the way here. That's 180 plus 30, that's 210. Got it. We're done with one of them. The second angle, well, you don't have to do as much thinking. Again, 1, 2. So this is still 30, the reference angle. But it's not about the reference angle. It's about the actual angle, which again is measured from the positive x. So when you come back around, you're 30 shy of 360. Which means that you're at 330. Make sense? Yeah. Okay, cool. All right. What? My pen froze. Okay, never mind. It's back. Okay. So, next is, well, yeah. So this one isn't much different. Like the only thing is that, like, you know, you add the 3, divide by 4, take the square root. But by the time you're done with all that, I can skip to your third step, which is cosine theta is equal to plus or minus root 3 over 2. Oh, and you needed to write plus or minus because you took the square root from the second step to the third step. As I've already said earlier, twice, And as you already know, when you take the square root, you have to write plus or minus. That's why it's both plus or minus. Got it. So then once you're there, since it's both plus or minus, because you had to take a square root, well, you're looking at positive and negative values of cosine. That means you're looking in all four quadrants. Because, well, it's positive in two of them. It's negative in the other two. So that's all four quadrants. So what you would do is draw reference triangles on all four quadrants. 1, 2, 3, 4, and label the reference triangles so that cosine is root 3 over 2. Cosine is adjacent over hypotenuse. So that's root 3 right here and 2. Again, you don't need to worry about the negativeness and positiveness because, well, you took care of that through the quadrants. Okay, so if you put theta here and theta here, theta here, theta here, right? Like this has to be 1 root 3, 2. So this angle here has to be the one across from the 1 on a 30, 60, 90. How do I know it's a 30, 60, 90? Because of the numbers involved. 1, 2, and root 3. So those two triangles, see, they're so crucial in trig. So anyway, that's 30. Well, now that you figured that out, the reference angles are all 30. That's not going to change. Once you know one of them, you know all the other reference angles. But it's not about the reference angles. It's about the actual angles. Well, the first one is easy. They're all measured from the positive x. That's just 30. The second one is keep going. That's 30 shy of 180. So that's 150. The third one is 30 more than 180. That's 210, blah, blah, blah. And the last one, obviously, is 30 shy of 360. We go all around, stop there. So that's 330. Anything unclear? Okay, cool. So the next one, well, yeah, so in the next one, you need a little bit of factoring work, right? So in 11, we're doing well with time, yeah. So 2 cosine theta, blah, blah, blah. So again, it's screaming factor me. And what is it that's saying factor me when you look at 11? It's okay. It's okay. Sorry. So say that again. It's okay. So like on the slightly more advanced questions, that's like all of the ones beyond 9 and 10, you just have to think about factoring, right? So on 11, there's one thing that's telling you factor me. What is it that's telling you factor me out? Yeah, sine is in both terms. So it's saying factor me. So you take out the sine. So when you do, you get sine theta and then times. Well, from the first term, you have 2 cosine theta left. And then you have plus root 2 equals 0, right? Okay, so on the one hand, you have sine theta is equal to 0. And then on the other hand, you have this is equal to 0. So that says 2 cosine theta plus 1 plus root 2 is equal to 0. So this is the zero products property that you learned like a couple of years back in that summer algebra class, right? You have A times B equals 0. Two things being multiplied equals 0. That means A is 0 or B is 0. So that's why I had to set both of the factors equal to 0. That should be pretty straightforward, but just making it abundantly clear. I'm pretty sure you know that. Anyway, we factored out the sine, and then we got a product between sine and 2 cosine theta plus root 2. So we have to set both of them equal to 0. Well, on one of them, sine theta is equal to 0. So that's quadrantal angles. Anytime you have any of them equal 0, it's about the quadrantal angles. And since you already know how to graph sine, for the quadrantal angles, the way, like when they're equal to 0, the way I'm going to have you answer it is using the graph. So remember, if you just draw one cycle, because again, we're still looking between 0 and 360, then this is pi, and this is 2 pi on one cycle of sine. But 2 pi is 360. And pi is 180, but we don't really care. All we know is that, like, and looking at a graph of sine between 0 and 360, we've covered the intervals that we're asked to look at the start of the set of questions. It says look between 0 and 360. It says 0 is less or equal to theta is less or equal to 360. So again, I am drawing the graph for sine because it's equal to 0. For only when they're equal to 0, you do this. You draw one cycle of sine or you draw one cycle of cosine. And remember, cosine is the one that starts at 0, 0, but otherwise, at 0, 1, but otherwise it goes much the same way. This is 2 pi, which is 360, and it's 1 there, and it's 1 to start at 0, right? So just reminding you, if had it been like cosine theta equals 0, this is the graph you'd use. But we're on sine, so let's get back to our blue graph. Well, now that you've got the graph of sine, look, it's very simple to figure out where it's equal to 0. It's where it touches the x-axis. Right there, and right there. So from this one, you get 3 answers. X equals 0 degrees, and then 180 degrees, and then 360 degrees. And we have to write all 3 because, again, at the start, when they gave you the interval, they said 0 is lesser or equal to. Theta is lesser or equal to 360. So it includes the endpoints, 0 and 360. So we needed to report both of these as part of our answers, and 180. Again, these are the places where sine is equal to 0 based on the graph that we could see, like, right? Okay, now for the next one, for this other factor, we have to subtract root 2 from both sides. That gives us minus root 2. And then we go over 2 over 2. So we go cosine theta is equal to negative root 2 over 2. Now, this one, very important detail here, love, like very important, which is you have root 2 over 2. Well, remember, if you have 1 over root 2 and you rationalize it, like you multiply by root 2 over root 2. When you do that, you get root 2 over 2, right? And so root 2 over 2 is the same as 1 over root 2 before you rationalize it. And the reason why I'm laboring this and mentioning it is because, well, there is no special triangle that involves 2 and root 2. There's one that involves 1 and root 2, and there's another that involves 1, 2, and root 3. So that's why I like this one you really need to pay attention to and recognize that root 2 over root 2 is just 1 over root 2. So then on the next step, you go cosine theta is equal to 1 over root 2. So then now you know it's about the 45, 45, 90. Because, yeah, well, so similarly, if you get root 3 over 3, if you unrationalize the denominator, that's really 1 over root 3. Because if you multiply by root 3 over root 3, top and bottom, you get root 3 over 3. So similar idea to the root 2 over 2. Pay attention to this part. Very important. Anyway, but it's negative. And it's cosine. All students take calculus. Tells us cosine is positive here, so we X that out, and positive there. So the reference triangles we draw have to be in the third quadrant and in the second quadrant. And we need to label those two reference triangles so that cosine is, again, now that we've figured out which quadrants, you can ignore that negativeness, and you just need to ensure cosine is 1 over root 2. And that's the adjacent is 1, and this is root 2. Simple. This is 45, and this is also 45. And so both reference triangles angles are 45. Right? Okay, got it. But the actual angles are measured from the positive x's we know. So one of them is 45 shy of 180. Let me do that in a different color that stands out. I'll do it in green. So one of them is 45 shy of 180, so that's 135. And the other is 45 more than 180, and that is 225. So from this one we get 135 and 225. And, so we have a total of 5 answers. 0, 180, 360 from the first factor, and then 135 and 225 from this factor. Any question about this? No. Okay, got it. So 12, tell me how I should start. Uh-huh. You are on the right track. Like, your first instinct is always great. And by the way, again, excellent job on the SAT. I for some random reason, like, I thought of that. But yeah, your first instinct I guess because I want you to trust your instinct on that also. Your first instinct is always great. So I think you were going to say subtract tan squared from both sides. You definitely want to do that because you want a number on the other side. So when you do on the left side, you're going to be left with tan squared theta plus root 3 tan theta equals 0, right? And so then now now you want to factor because, well, if you let tangent theta equal, like if you let tangent theta equal u, what you've got is u squared plus 3u is equal to 0. Obviously, we can factor out a u. We could be like u times u plus root 3 is equal to 0. So that means u is equal to 0 or u is equal to root 3. That sounds like negative root 3. I have really bad grammar. Okay. So anyway, u is tangent theta. Yeah, I laugh at my own jokes. So tangent theta is equal to 0. Darn it, you're supposed to laugh with me. So hey, what's going on? Are you even there? Yeah. No. Okay, no problem. Sorry. Let me pause. Question. Do you have any question? Mm-hmm. Okay, cool. So, so tangent theta is equal to 0. Well, I'll just tell you that tangent theta is equal to 0 only at 0, right? Like, and again, for when whether it's sine or cosine or tangent, when they're equal to 0, really the only thing you have is the graph. And if you recall, the graph of tangent, one cycle of it looks like that, and it goes through 0, 0. So it's equal to 0 when theta is equal to 0. So there we are. And then for root 3, well, again, figure out the quadrant. So all students take calculus says that the quadrants where tangent is negative, so all of them are positive here, and then, tangent is positive here, so the places where it's negative are the second quadrant and the fourth quadrant, and you want to label the reference triangle so that tangent is equal to root 3. Well, it's really root 3 over 1. Again, you can ignore that negative sign because, well, you've pinned down which quadrants. So that's second quadrant and fourth quadrant, right? So it's just root 3. Well, it's root 3 over 1. So tangent, but tangent is opposite over adjacent. So that means the opposite is root 3, the adjacent is 1. Root 3 and then 1. So that means that this is 60, the reference angle. This is 60. Well, but the actual angles, they're measured from the positive x. So one of them is 60 shy of 180. So that's 120. And the other is 60 shy of 360. So that's 300. Fair? Yeah. Okay, no problem. All right, so the next one. So you know how, like, I said, like, let tangent theta equal u, and then, you know, we got into an equation that says u blah, blah, blah. So that wasn't crucial. You didn't need to do that, like, for the previous problem because, well, you could have just factored out tangent. Maybe the u didn't help. Like, but on problems like 12, 13, and 14, on problems like 13 and 14, it's crucial that you let the repeated trig function be u, because then it's easy to see that it's a quadratic. So for example, on 13, if you let u equal cosine theta, then the equation becomes u squared minus 2u is plus 1 equals 0. So it's crucial that you make this substitution again on problems like 13 and 14. Now here, that's a quadratic. And it's the quadratic u minus 1 all squared. Because if you FOIL u minus 1, then you're going to get u squared minus 2u plus 1. So first, you need to use your u so that you can see it's a quadratic. Second, like, obviously you need to be able to recognize that that's u minus 1 squared. And I don't care how you do that. You can use your factoring method. You're fantastic at factoring. So, like, and you had your own way of factoring stuff. So do what you do best. And, like, somehow figure out that this is it. Well, okay, if it's a repeated factor, like, we don't need to set u minus 1 equal to 0 twice. We don't need to say u minus 1 equals 0, u minus 1 equals 0. That's redundant. So just write u minus 1 equals 0 once. because that's what it is, like when it's repeated, right? So that says u equals 1. But it's not u, it's cosine. Cosine theta equals 1. Oh yeah, I forgot. So you use the graph of sine and cosine and tangent only, not just when they're equal to 0, but also when it's equal to 1. So equal to 1 is also about quadrantal angles, right? So you go, oh yeah, like I'm just going to draw one cycle of cosine, where I'm supposed to look between 0 and 360. So you do that. You draw one cycle of sine. This is 360. And it's very clear that cosine, which is what I just drew, sorry if I misspoke and said sine, cosine is equal to 1 at the two red dots. One of them is theta equals 0. The other is theta equals 360. So for like when sine, cosine, and tangent are equal to 1 or equal to 0 at the end or wherever you end up saying that, the easiest way to figure that out is not by drawing reference triangles. We do that for the other ones, when the root 3 blah blah blah, those numbers are involved. But when it's equal to 1, the easiest way to answer it is to graph. Graph one cycle of sine, graph one cycle of cosine, and then from there, look up where the y values are 1 or 0 and pick them out quickly, like I just did. So we just finished question 13. So let me know if you have any questions, or I'm going to move on to 14, our final one. Okay. All right, cool. And I might only need to get you started on 14. I think you got this. So minus 9 sine theta is equal to 5. So yes, I said like, get it to say equal a number, but not when it's quadratic. This is quadratic in sine. So what we said, and we did say when it's quadratic, you want it to equal 0. And how do I know it's quadratic in sine? Because you have sine squared and sine unsquared. So it's quadratic. It's quadratic in sine. So x squared plus 2x plus 1 is quadratic in x. U squared plus 2u plus 1 is quadratic in u. This is quadratic in sine. Anyway, just use the sine. You subtract the 5 and you get here. Now you make your u. So you let u equal sine. So you have 2u squared minus 9u minus 5 equals 0. And you had your own way of like factoring quadratics that look like this. I do it by the AC method, multiplying 2 and negative 5, blah, blah, blah. Once you factor it, you're going to get like 2 factors, right? And you set each of the factors equal to 0 and proceed as we have done previously. Now, I could go through that with you, or you can say I got it and we could be done. Whatever you want. But tell me, like, well, honestly, if you need help. Yeah, exactly. So factor and set each of the factors equal to 0, and then use all the similar methods that we use, which is if it's equal to 1 or 0, draw a cycle of sine and cosine. If it's about the other numbers, then use the special triangles and figure out which quadrant, blah, blah, blah. Make sense? Yeah. Okay, cool. All right, good luck, but yeah, as a final, you don't need the luck, you're like skilled, and we've prepped really well just now. As a final reminder, like, pay attention to the quadrants, like, very, very important, that's all. Okay, all right. Have a wonderful night. And is this everything that you have to do, or like, do you have a lot more work after this? Yeah, yeah. Do you ever? Are there days when you don't do